This is section 9.2, the quadratic formula. We're finally going to get the most powerful tool for solving a quadratic equation. If we start off with ax squared plus bx plus c is equal to 0, then we can use the following formula to solve the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This can be sung to the tune of Pop Goes the Weasel. And I can't believe I'm doing this because I used to tell my students if I ended up on YouTube doing this, they would fail. But here we go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, that's it. Not doing it again. All right. So a couple things we have to notice. Well, first of all, you might be wondering where this comes from. If you take this original equation and you complete the square on it, using a, b, and c as your numbers, you get this. So divide everything by a, find the magic number, add it to both sides, factor, use the square root property, all of that, you end up here. Okay, so that's exactly where that comes from. A couple things we need to notice before we start working problems. You want to notice that the initial equation is equal to 0. Okay, we have to have that 0 there, or we won't have the proper signs on our a, b, and c, and all of this gets messed up. You need to make sure that your fraction bar extends all the way. Don't let the negative b slide off. That happens a whole lot, and you'll have negative b off to the side and plus or minus this over this. Remember, this negative b is being divided by the 2a as well, so if you lose the fraction bar, you've changed the value of everything. Okay? Double check that you have the plus or minus when you write the formula. It's easily forgotten. And again, if you get in the habit of splitting up your answers, you're less likely to make that mistake. Okay? And just like when we're factoring, these problems are a whole lot easier if a is positive. So that means we may want to rearrange this, or we may want to multiply everything by a -1 so that we have a positive number right there. It's an easy fix. We just need to do it. Okay, so let's work some problems. All right. So we want to use the quadratic formula to solve these. X squared plus 3x minus 28 is equal to 0. First of all, we have our 0, and our a, b, and c are the coefficients here. A is the number in front of x squared, so this is 1. B is the number in front of x, so it's 3. And c is our constant, which is negative 28. Okay? So let's plug into the formula, which I have written on a card right here. Okay? X equals negative b. That some people read that as the opposite of b. So I'm just going to change the sign on whatever b is. So since 3 is positive, I write down a -3. If this had been -3, I would write down a +3. Plus or minus the square root of, I don't put the bar on it because you have to make sure the bar extends all the way. And I don't really know how long what I write is going to be. I need b squared. You want to put this in parentheses. It doesn't matter so much when you have a positive number, but if it's negative, you need to include the parentheses, so just do it all the time. B squared minus 4, because the 4 is in the problem, 4 is in the equation. A, C, okay, and this is all over 2a. 2 times a, which is 1. Okay, now after here, it's arithmetic. Make sure you're following order of operations and all that kind of stuff. And you really want to simplify this part under here first. And the reason for that is I have this written down on a card here. B squared minus 4ac, which is the part that's under the radical, is called the discriminant, and it tells you what kind of answers you're going to get. If what's underneath the radical is 0, you're going to get one solution, one rational solution, meaning it could be a fraction. If b squared plus 4ac is greater than 0, so it's positive, and it's a perfect square number, so like say we get 16 or something like that, then what we have is we're going to get 2 rational solutions. So we're going to have 2 answers that are going to look like fractions. If the discriminant is greater than 0, but it's not a perfect square, so say we figure this out and it's 10, which is not a perfect square, we're going to get 2 irrational solutions. So we're going to get 2 answers, and both of them are going to have a radical in it. Now, if the discriminant is less than 0, then we would be taking the square root of a negative number, and we're going to get two complex solutions. Okay, so if you do this part first, it's going to tell you what kind of answer to expect. And also, this is important when you start using quadratics for real-world problems. Sometimes you're going to see that something is wrong here, and you'll be able to catch it more quickly because you know what kind of answer you need or expect for the type of problem you're working. All right, so let's figure this out. In order of operations, the first thing we do is parentheses, so we simplify inside parentheses. Well, all of our parentheses are simplified, but that's also means a grouping symbol, and we have two grouping symbols here. We have the fraction grouping symbol, so the top is one part, the bottom is another part. And we also have the radical, which is a grouping symbol. We need to simplify inside here before we can take the root, okay? So this is equal to -3 plus or minus the square root of 9. And then -4 times 1 times -28 is going to be plus what? It's 112. Okay, and this is going to be over 2 times 1 is 2. So I have -3 plus or minus the square root of, that's going to be 121 over 2. 121 is positive and it's a perfect square. So I expect to get two rational solutions. Okay, the square root of 121 is 11. So I have -3 plus or minus 11 over 2. So x is equal to this. Now I have two answers in here that I can simplify. If there were a root in here, maybe I wouldn't be able to simplify anymore. If there's an I in there, maybe I couldn't do anything else. But I do have two problems here. X is equal to -3 minus 11 over 2, which would be -14 over 2, which is -7. So that's one of my answers. And then I have x is equal to -3 plus 11 over 2, which would be 8 over 2, which is 4. So your two solutions are 4 and -7 in any order. I got regular whole numbers, and that tells me that this thing could have factored. This is an easy factoring. It factors as x plus 7, x minus 4. Imagine setting each of these equal to 0, and you'll get these answers more quickly. The quadratic formula always works, but sometimes it's more tool than you really need. Okay? All right, so let's try this one. X squared minus 4 is equal to 2x. We need a 0, so I'm going to move this over here since that's a positive 1 right there, and I know I want that to be positive. So that will give me x squared minus 2x minus 4 is equal to 0. Okay, so our A is 1, our B is -2, and our C is -4. If you had tried to do this before moving this over and you read this as B, you would have the wrong sign here, which messes everything up. Okay, so let's plug this into the formula. X equals the opposite of B. B was -2, so I write 2, plus or minus the square root of B squared, -2 squared in parentheses, minus 4 times A times C, so times 1 times -4, and then draw your radical bar. This is all over 2 times A, which is 1. Okay? So I have 2 plus or minus the square root of -2 inside parentheses squared is 4. Minus 4 times 1 times 4, that's going to be -16, so this is plus 16. All over 2. So this is 2 plus or minus the square root of 20 over 2. Now, so my discriminant is 20. 20 is a positive number, but it is not a perfect square. So we expect two irrational solutions. Okay, so the square root of 20, we've done a couple of times, I believe. It's right in here. If you cover this part up, it's going to be 2 square roots of 5. So x is equal to 2 plus or minus 2 square root of 5 over 2. Okay, we are almost done. We've dealt with everything except reducing our fraction overall. If you look here, each of these is divisible by a 2, and I have a 2 right here. There are two ways you can think of this. The way the book is going to do it, the way most people are going to describe it to you, is you're factoring out a 2, and this is 1 either plus or minus the square root of 5. You distribute 2 times 1, you get the 2. 2 times the square root of 5, you get this, and you're going to have either plus or minus depending. And this is over 2. And then these two reduce, and you've got your answer here. The other way of doing this would be to split this up into two fractions as 2 over 2 plus or minus the square root of 2 over 5 over 2, and then you reduce each one and you get this as well. This works more often than this. Okay? So your two answers are 1 minus the square root of 5 and 1 plus the square root of 5. We got our two irrational answers that the discriminant predicted.